Okay, so now we're on slide number 3 looking at question number 6. This question says, the diagonal of a rectangle makes a 35-degree angle with the base. If the base of the rectangle is 10, find its area. Now this question looks a lot like number 5, but there is a little twist that makes it more challenging, so you're going to really have to pay attention. Let's start by drawing a diagram of a rectangle. I'm also going to include in this diagram the diagonal, because they reference it in the question. Okay, so it says the diagonal of a rectangle makes a 35-degree angle with the base. So I'm going to call this 35, and they tell us that the base is 10, and they want us to find the area. Well, since this is a rectangle, I'm going to start by just writing down the formula to find the area of a rectangle, which is base times height. I'm going to rewrite this using blanks in place of the base and the height. Now, it tells us that the base is 10, and we've already labeled that in our diagram, so that's very easy. Now, the height, we don't know. And unfortunately, this triangle, ABC, I'll throw some letters here so we can have a conversation. This triangle ABC is not a 30, 60, 90. It is not a 45, 45, 90. We can't do the Pythagorean theorem because we only know one side. But we can do basic trigonometry. If I call this angle 35 my reference angle and I mark it as such, then this side across from it would be known as the opposite side, and the side that's marked as 10 would be the adjacent side. So the question becomes, which of the three basic trig ratios involves opposite and adjacent? And the answer to that is tangent. So we can set up a proportion that says the tangent of 35 degrees is equal to h over 10. I can put tan 35 over 1, and I can cross multiply and say that h is equal to 10 tan 35. Now to figure out this specific answer here, we're going to need to queue up a calculator. It just so happens that I have one right here. I'm going to start by looking at the mode and making sure I'm in degree mode. This particular calculator right now is in radians, so that's not going to be good. So I've made it flash in degrees, and that's what I want. So now I'm going to do the calculation. 10 tangent 35. And when I do that calculation, I get a height of about 7. It's 7.00. So I'm going to go ahead and in that box, I'm going to put in 7. 10 times 7 is 70, so the area of this rectangle is 70 square units. And we used trigonometry to get it, so it was pretty cool. Let's look at the last problem on this slide. Find the area of the shaded region. You might think of this as a concrete deck surrounding a pool or a wooden frame surrounding a picture. So our objective is to find the area of this shaded region, but if you squint, it kind of looks like a square donut. It's not completely a full rectangle. It's a rectangle with the inside removed, which happens to be the shape of another rectangle. So our strategy here is going to be to subtract. I'm going to find the area of the big rectangle, which has dimensions 10 by 20. So just to make sure you know what I'm looking at, I'm going to outline the big rectangle in blue. Okay, so the dimensions are 20 by 10, so the area of the blue rectangle is going to be 20 for the base times 10 for the height, which is 200. But that, of course, is too much area because there's this whole portion in the middle that's been removed. So I'm going to jump to the middle now, and I'm going to shade that red so you know exactly what it is that I'm looking at. Now, the dimensions of this red rectangle are 14 by 6. The base is 14, and the height is 6. And the product of these two numbers is 84. So if I start with the big blue area, which is 200, and I take away the 84, I'm going to be left with just this gray shaded region. So 200 take away 84 is going to be 116 square units. Great! Let's go on to our final slide. Okay, so we're on the fourth and final slide looking at question number 8. This question says, find the area of the figure below. Assume consecutive sides meet at right angles. And the first thing that strikes me about this diagram is that it's not a rectangle and it's not a square. So I'm wondering, well, what's it doing in this section if everything is supposed to be squares or rectangles? So this is going to suggest another strategy. And this strategy is something called divide and conquer. I'd like you to write that down in your packet if you're one of my students. What divide and conquer means is taking a region and dividing it up into smaller regions that you do know how to find the area of. So when I'm looking at this, it kind of looks like a capital L that's been tipped over. But if I go to this little corner right here, and I extend either this horizontal line that's labeled as 5 all the way over, or this vertical line labeled as 4 all the way down, I'll be able to create two shapes that are both rectangles. Now, oftentimes it doesn't matter which one you do. I think I'm just going to go straight down from this 4. So I'm going to create two regions. I'm going to call this Roman numeral 1, and I'm going to call this Roman numeral 2. And these are both rectangles. So I'm going to set my formulas up by saying the area of Roman numeral 1 is going to be base times height, and the area of Roman numeral 2 is also going to be base times height, but it's a different rectangle completely. So I'm getting myself set up. So I'm going to put these little blanks here, base times height, and this is going to be base times height for the other rectangle, and then I'm going to add them together. So I'm going to focus first on Roman numeral 1. And what I'd like you to notice is that the top of this rectangle is 3, which means that the bottom is also 3. And now let's switch to another color, and I'm going to look at the right of this rectangle. The right is 4, which means that this portion here is 4. This weird, awkward, kind of halfway up is 4. So this is a little strange. But we can fix that by looking at the way right. And this piece over here, we're now in Roman numeral 2. This piece here is 3 that I'm making pink. And if the right of this rectangle is 3, then the left is also 3, which means that this is also going to be 3. So there's a lot of things that are 3 here. Maybe I should go ahead and make this pink. All those pink segments are the same. And I'll do one last thing. The top of Roman numeral 2 is 5, which means the bottom of Roman numeral 2 is also going to be 5. So at this point, I think I have everything that I need to answer the question. Looking at this Roman numeral 1, it's a rectangle, its base is 3, and its height from the bottom to the top is going to be 3 plus 4 or 7. So the base is 3 and the height is 7, which gives us an overall area of 21 for that specific region. Going to Roman numeral 2, our base is 5 and our height is 3. I think that's actually pretty obvious. And now we'll multiply those together and get 15. And now we're simply going to add the results together. Here's the area for Roman numeral 1, here's the area for Roman numeral 2, and we end up getting 36 square units. And we did that using this method called divide and conquer. It's a great method. Now looking at number 9, we're going to implement yet a different strategy. In number 9, the directions are the same. It says find the area of the figure below. Assume consecutive sides meet at right angles. For this, I'm going to implement a strategy called the subtraction method. If you're a student in my class, I'd like you to write that down next to number 9, so you know for future reference that you solved it using the subtraction method. In the subtraction method, I'm going to encapsulate the diagram inside of the smallest rectangle that I can. So right now we've got this funky looking shape, but what I'm going to do is I'm going to surround this in a rectangle. And to do this, I'm going to project a line straight down, and I'm going to project a line straight over, and I'm going to project a line straight over by this 2, and I'm going to go up here to where this 8 is, and I'm going to go straight over, and then where this 5 is, I'm going to go straight up. So we've now taken this figure and we've sort of closed it inside of a rectangle. But in doing this, we've grabbed a little bit too much area than I need. I don't need this region here. That was never there in the first place. And I don't need this region here. That was never there in the first place. So a couple things. I'm going to start by finding the area of this big rectangle. And to do that, I'm going to have to do a little bit of extra little work here. So looking at this little rectangle down here, if the top of this rectangle is 3, then the bottom of that same rectangle is going to be 3. That 3 might be a little hard to see. Maybe I'll switch to a different color. Now over on this little rectangle, if the bottom of the rectangle is 4, then the top of that same rectangle is 4, which means that from total left to total right is going to be 8 plus 4, or 12. So let me put some lines in here to indicate that. I'll draw these little arrows. And let's do one more thing. If the left of this rectangle is 3, that means the right of this rectangle is also 3, which means from top to bottom, we have 5 plus 3, or 8. So I'm going to go ahead and put these little lines here. A lot of times if you were to look at blueprints, they would have these little lines like this to indicate overall measure. So I'm now going to find the area of this big rectangle. The area of the big rectangle is going to be 12 by 8, and that product is 96. But it's a little bit too much area. We need to get rid of those two little rectangles down at the bottom. So I'll call this one Roman numeral 1, and I'll call this one Roman numeral 2. So let's focus on Roman numeral 1 first. The area of Roman numeral 1 is going to be comprised of the dimensions 3 by 2, or 6. And then let's just pick another color. We'll go to region 2. It's a rectangle whose dimensions are 4 by 3, which is 12. So I want to start with this big rectangle of 96, and then I want to peel away the 12, and I want to peel away the 6. So really, I want to peel away 18. Now, 96 take away 18 is going to be, I think, 78. So this is 78 square units. Okay, so we're done with this lesson on finding the area of squares and rectangles. A couple of things worth noting. Always include a diagram. Always start by writing down the formula. That often guides you through the problem in terms of what you need to find. Sometimes you need to use Pythagorean theorem. Sometimes you need to use 30, 60, 90 or 45, 45, 90. Sometimes you have to do a SOHCAHTOA trig problem. Sometimes you have to divide and conquer. Sometimes you're going to use the subtraction method. There's a lot going on here in this basic little chapter on squares and rectangles, which seems so basic. There's a lot happening. So make sure you take good notes, and until next time.